In this video, we're going to do just a quick refresher on some algebra, some equations of lines using slope, calculating slope, and so forth. So on slide 11, we saw this graphic, and we had an equation for the line 2x1 plus 3x2 equals 19. So we're just going to walk through how we got that equation real quick. So if we look at our vertical axis, that's labeled as x2. We often think of it as y. Here they call it x2. If the x2 seems more confusing to you, go ahead, cross it out, replace it with a y. Now our horizontal axis is labeled x1. The most common equations that we use are y equals mx plus b. This equation is the slope-intercept form. The slope is our m variable, and the y-intercept is the b. The other common equation that we see is point slope. So that's y minus y1 equals m times x minus x1. This again, our m variable is the slope. Slope we know is rise over run. So how much we go up or down divided by how much we go right or left. So that could be y2 minus y1 divided by x2 minus x1. It's the change in the vertical direction divided by the change in the horizontal direction. So we have 2 points here. We have 0, 6 1/3, and 9 1/2, 0. That's our second point. These points are a little bit more confusing because they aren't whole numbers, so we're going to be dealing with fractions as well. So we can label our points. We can call them x and y. That's what we'll use in our calculations so that they match up with the equations, and then at the end we'll take a look back and we will replace our y variable with the x2 that they use in this problem. So we will call this x1, y1, and x2, y2. Let's go ahead, just for the sake of keeping things straight, and we're going to call that y for a second. So in order to find the equation for this line, we need to use the information that we have. Well, we have 2 points, and we can plug 2 points into the equation for slope. So let's start there. So we want y2 minus y1 divided by x2 minus x1. So just matching up our variables, we have y2, which is 0, minus y1, 6 1/3. We'll leave it like that for right now, and then we will change it to a fraction in just a second. Then we have x2 minus x1 in our denominator, so 9 1/2 minus our x1 value of 0. So now changing this into fractions, we have 0 minus 6 1/3. Well, 3 times 6 is 18, plus 1 is 19, so 19/3, divided by 9 1/2, so 9 times 2 is 18, plus 1 is 19, 19/2 minus 0. Or we have a negative 19/3 divided by 19/2. Now remember, it doesn't matter where we put this negative symbol. It can be up in the numerator, it can be out in front of the whole rational expression, or it can be in the denominator, just as long as we only have one. Okay, so now let's remember how to deal with fractions within fractions. What we have is equivalent to moving the 3 into the denominator and this 2 up into the numerator. So we really have a negative 19 times 2 divided by 19 times 3. Our 19s cancel, and we're left with a negative 2/3. So our slope, m, equals negative 2/3. So now we need to use this and find the equation for the line. We can use either slope-intercept or point-slope form. Since we are given a couple points, let's go ahead and practice with the point-slope form. So y minus y1 equals m times x minus x1. Now it doesn't matter what point we use as long as we just use one of them. We're consistent with our coordinates. So let's go ahead and use our second point, 9 1/2, 0. So 9 1/2, 0. And we know that our slope, we just calculated it to be negative 2/3. So we have y minus y1, which is 0, equals our negative 2/3 times x minus x1. That's the 19.5, or we know from before that that's the fraction 19/2. So now on the right side of this equation, we want to multiply. We have negative 2/3 x. A negative times a negative will be a positive. So we have 2 times 19 divided by 3 times 2. Our 2's cancel, and we have negative 2/3 x plus 19/3. Now, this still doesn't quite match up with the equation that we have way up there. So what we currently have, y minus 0 is y, equals negative 2/3 x plus 19/3. So now, if we wanted to get rid of these fractions, we could multiply everything, all three terms, by 3. So that's going to give us 3y equals a negative 2x plus 19. So we're getting closer to what they have up there in that equation. But they have both the x1 and the x2 terms on the left side of the equation. So that means we would move our negative 2x over, or we would add 2x to both sides. So we have 3y plus 2x equals 19. Then the last little part that we have to look at or remember is that instead of y, they use x2. So it should be 3x2 plus 2, that variable was x1, equals 19. And again, this one was a bit tricky because we weren't dealing with whole numbers. But the first thing to do when you have 2 points is to go through and calculate the slope with your m variable. Then you can plug it back into either one of the equations and figure out your equation for the line.